The captain stood in the sail with a thermos in his hand and the horizon behind him like a promise he had no intention of keeping. He didn't raise his voice the way real captains never need to. He let the words land and become gravity. "Never surface near those formations," he said. "Not for any reason. Not for command, not for science, not for curiosity." It was a rule, and in the cold geometry of that Arctic morning, it sounded less like instruction and more like an invocation, the kind men say when they want to keep something from waking. The captain's thermos steamed in the wind. In the steam was the shape of the warning. You remember that steam longer than the sentence. We were a Deep-Recon submarine, small, slow, built to listen and to get close to things others would not touch. Think of the NR-1 as a reference point, a compact, nuclear-powered research sub built to crawl the ocean bottom and stare, long and patient. That's the kind of platform that sends men below the ice to take pictures of the floor, to map under-ice topography, and to listen to things that do not speak on ordinary channels. NR-1 and its kin were not made for smashing through polar ice like an icebreaker. They were made to be precise, to hug the bottom, to hold position, and to use instruments the rest of the fleet did not carry. What the captain was talking about were ice formations the maps call many names: pressure ridges, hummocked ice, multi-year flows, and massive submerged ice keels that reach far below the visible surface. To a man who reads sonar, the ocean under the ice is not empty. It's a room with pillars and hanging chandeliers. Those keels can reach tens of meters down and punch through a subsail if you're unlucky enough to meet one while you try to push through the ice. Upward-looking sonars, the silvery instruments submarines use under the pack to profile ice draft, show the under-ice world like a city map: ridges, leads, open water, polynyas, persistent open areas, and teeth. We had those maps, and we had tools. The rule existed because the tools are blunt against time, and the ice shifts faster than you can print a risk assessment. An ice keel looks like a skyscraper on the sonar, all shadow and menace. It doesn't announce itself, it waits. We learned the complex names in the chow line and turned them into shorthand: keel, stove in, lead, polynya. Each carried a weight. A polynya is a hole in the ice, an honest hole where a sub can surface. A pressure ridge is a seam you don't want to see from below. The difference between a polynya and a trap can be 3 feet of ice, and the difference between 3 feet and 9 feet can mean the difference between surfacing safely and drawing an angry hole in a hull. Modern accounts and practical write-ups on surfacing through ice make that painfully clear. Typical fleet boats can punch up through a few feet of ice at a chosen spot with reinforcement. Purpose-built polar boats can take more, but the wrong spot kills you. Picking the place to surface is a craft, not a guess. Popular mechanics, people fall in love with headlines about submarines surfacing through ice. No one loves the list of things that can go wrong. We were on a long recon mission under seasonal pack. For weeks, our world had been the thin green glow of consoles and the white pulse of the ULS upward-looking sonar, Echo. A rain of ice draft numbers, a banded landscape read out in pings and profile graphs. The ULS gives you a constant cross-section, the ice drafts above, the keels under them. Those data sets collected by subs for decades tell you where the heavy stuff is likely to be, and they also tell you it moves. Submarine teams rely on historical drifts and current models, but the ice has moods. Data from Navy submarine upward-looking sonars shows variance in draft, shapes and frequency of ridges, and the changing mosaic of leads. It's an imperfect atlas that still saves lives. The ULS prints a skyline of the ice, but maps can be out of date the moment you finish ink. My job, I'll say this plainly, was the grimiest kind of reverence. I was mechanical by trade, pumps, seals, the slow friction of valves. But being a mechanic on a recon boat means you also listen. Gear sings different songs under ice. Bearings bruise in the cold. Condensate forms where it shouldn't. The outside temperature can whisper through the hull like a hand. I learned quickly the economy of small sounds, a pump that yawns wrong, a scrub of sonar frequency, a sudden drop in oil temp. Those were the things you fix, because if you don't, the small things will become enormous. A man who can hear his engine's temper knows when the ocean is about to change its mind. The rule not to surface near certain ice formations was not a line in a manual. It was a story passed down from one watch to another until it had mass. That's how useful things turn into law in closed places. Someone survives a bad morning and then uses the story to protect the rest. On our first day, the XO pointed at the map and said the line one way: stay hostile to the edges, don't hunt the hummocks. He looked at us long enough that we could feel the rules settle.
But a rule is only a shield if you believe in it. You can tape your belief to your reality, but sometimes reality peels right through the tape. Rules arrive as comfort, then become shackles if you ignore what whispers beneath them. Anomalies began in small ways. The first was a sound we did not have a name for, a distant, low scraping, like a glacier shifting under 1,000 years of patience. We were running at 200 meters, the sail clipped for quiet, and the array picked up a rhythm that didn't resolve to any known echo type. We ran the recordings through filters and matched the pattern against archived ULS profiles. The math gave us a slowdown, a non-Newtonian scraping, a known craft. The sound did not match a hull strike, nor did it fit a keel echo. It was something that ran along the ice, not through it, a vibration that felt like a message. The ice knocked in a rhythm we had no code for. Then there were the lights. Under the ice, light behaves like a rumor. It filters through cracks, refracts through brine channels, and arrives as thin columns. But one morning, the forward cameras, we kept a low light pair to study fauna and topography, caught a blink at odd angles, not sunlight, not bioluminescence. The screen recorded 3 faint vertical pulses, small and blue, beneath an overhang. The exposure stretched and contracted like breathing. Corby, our signal tech, ran a spectral analysis, and the energy signature didn't match any known biological glow or stray surface reflection. It was stationary and repeated, as if fixed to the ice itself. I still remember the small click in the wardroom when the tape came up on the tiny projector. Men who had eaten together in scarred messware sat and then stilled. The captain said nothing. He had the sort of face that reads the ocean the way a weathered map does, not in words, but in bruises. He walked over to the sonar rack, ran a slow finger along the digits, and simply said, "We don't say the wrong name for light. Lights under ice are either life or an omen. We did not yet know which." The data we had to work with is public in fragments. Scientists and the Navy have published troves of submarine ULS ice draft data. The imagery shows a lumpy, broken skyline. Research papers on ice relative navigation explain how underwater vehicles plan missions around keels and leads, and how complexity grows in multi-year ice. Those reports tell you one important practical thing. Even with upward-looking sonar, you only get slices. The world between slices devices is a room you have to move through slowly. If you misjudge the interval, you meet a keel. If you misread a polynya, you break yourself trying to push through what looks like a hole, but isn't. The charts help, but they are not scripture. Maps are a lifeline, but the ocean keeps the margins where it eats men. The captain gave us a new order that day, a clause woven into the rule. No surfacing within a radius of X of any hummock cluster that showed pulsed light or anomalous mechanical signatures. We were told, collect the data, annotate the raster, wait for the mothership's analysis, and do not surface. A technician across the table wrote, "Do not surface," in all caps on the mission board. It was the kind of sign men put up to keep superstition at bay. But the sign was also a promise. If we obeyed, we kept our heads under the water. If we disobeyed, we told the ocean we had questions. Promises on whiteboards have a peeling human smell when they're made under pressure. We began to test our limits. You test limits the way men in tight spaces test boundaries, quietly, with small steps. Each step measured and recorded. The sonar operator would angle the ULS beam and take a sweep across the suspected area. We modulated speed and depth, took microprofiles, and compared them to archived transit lines. We logged the drift, ice moves in eddies and in swarms, and we mapped a dance of shadows. Each profile revealed more complexity. Keels that shifted, brine channels that sang, and thin cracks that ran for miles like hairline scars. During one long watch, the ULS sonar beam traced a keel that dipped and rose with a weird regularity. The draft pattern was like teeth in a comb, regular as a machine. The pattern suggested not random deformation, but a series of repeating ridges spaced at consistent intervals. For a scientist, that could be an interesting formation. For us, it read like a manufactured sequence. When the sea looks as if someone etched it in a template, you stop thinking of chance. At night, we argued in whispers. The ship is a crucible. Men talk differently inside it. The navigator muttered about tidal compression and thermal stresses. The engineer swore it was a new kind of pressure ridge caused by multi-year melts. The radio tech said it could be acoustic reflections off a submerged structure, maybe even a grounded object that had become a new island in the ice. Someone, always someone, threw the easy rumor. There are things up there man-made. The word hung like cigarette smoke. The truth was thinner. Sonar shows you outlines. It doesn't tell you the intentions. We had to work with what the instruments gave and what the eyes could not confirm. The captain said nothing beyond the rule. He wore the silence like armor. The ocean gives you a picture that always has missing frames.
Our mothership, the tender that supported us with comms and logistics, kept a cautious distance. It relayed analysis much like a slow drumbeat. Anomaly logged, continue under caution. We could request permission to surface in a safe lead and send a reconnaissance team with ice pilots, specialists who can ride the ice edge and measure thickness. But that takes time and a calm you don't always have when your ULS starts printing a skyline that looks like someone's bad architectural plan. One morning, a low-pressure system came through. The ice convulsed, and the ULS showed rapid deformation. A field of leads opened, and for a breath, the ocean gave wide, honest holes of black water. The captain considered surfacing in a legit polynya. We readied the mast and cleared the area. Watchstanders checked the charts. The ice pilots on the tender sent a cautious endorsement over the encrypted channel. Polynya stable for plus 30 minutes. Recommend surface with small team. The writ came in as code and numbers. In the wardroom, we said the words as if they were bread. Polynyas taste like salvation, only until you test their edges. We got to a point where men began to bring talismans to watch. A picture, a coin, a stiffened handwritten slip tucked into the helm. The rule had become not only an operational axiom, but also a superstition, a do-not-surface prayer. Sleep thinned in the racks,
because your dreams in the Arctic feel like a low-pressure system trying to climb your spine. And then, as if testifying to our caution, the anomaly took a small personal shape. It was Petty Officer Karev's joke at first. He was the sort of man who could find a way to make any problem into a punchline. He came back from a short bottom crawl with his gloves dirty and a face like a boy sneaking a treat. He shoved an ice chip across the table and said, "Look at this, found it under the keel-out, blue as a tooth, glow like a watch." He dropped it under the wardroom lamp, and we saw a sliver of ice that caught the light with a strange scintillation. Not like regular brine, not like clean ice. The chip held a pale bluish fiber inside, crystalline but regular, like a filament. Corby took it to the lab. Spectrography gave gibberish for a while. The fiber's refractive index wasn't a clean match for seawater crystals, nor for any organic biomaterial in the database. It was a notch between categories, an edge the machines could not name. Even the ice has seams machines are not taught to read. The captain didn't tolerate jokes after that. He walked the deck at dawn, thermos in hand, staring out at a horizon that was a knife. He let the rule be a line between us and the unknowable. He would tap the mission board and say softly, "We collect. We do not surface where the map does not say we may. We do not light. We do not tempt. There are rules made of physics and rules shaped by fear." The captain forbade both breaches. I kept that blue shard in my pocket for a while. You keep small evidence because the human brain is a jury that needs tokens to stay honest. The shard was so thin that you could see library of light inside it. It did not look like anything alive. It looked like glass that had tried to learn how to breathe. We keep trophies so our memory doesn't turn into a rumor.
They called it a test because tests have paperwork and witnesses and the comforting hum of formality. In truth, it felt like an offering. The ocean with a small, nervous human hand lifted to see if the sky would answer. The captain signed the Poligno chart in black ink, folded it, and slid it into the pocket of his parka. He didn't ask for volunteers. He only said quietly, "If you step into that hole, remember how to hold your breath, and remember this boat's name." You remember the name longer than the weather. We had the tenders go ahead on the comms, satellite imagery, ice pilot confirmation, and the FLAP, fractures, leads, and Polignas analysis, flagged one near our track as stable window, plus 30 minutes. In plain language, a real Poligna, not a false hole. Surfacing through a verified Poligna is standard Arctic tradecraft. The ULS and ice pilots do most of the work to make sure the mast will not hit an unseen keel. The tender's message gave legalese and a line you could sign in a report. Surface with caution. That language is supposed to flatten risk into numbers. We prepared like surgeons. The ballast team ran a drill cadence that had been rehearsed since the Cold War. Check the upward-looking sonar sweep. Hold at periscope depth. Ping the ice draft arc. Slow the pumps to avoid sudden bow rises. The deck watch made a strip chart of the ULS trace and circled the lead in red. The men who rode in the mast got the harnesses. The lookouts shook their gloves until their hands were steady. People in pressure suits feel more naked than anyone else. The harness makes you weightless. The light makes you small. We went up slow. The water around the Poligna felt wrong. Not in temperature, but in insistence. The ULS printed vertical teeth that made the paper look like an angry skyline. Those teeth were the keels, and their spacing was weird, too regular. They looked manufactured or patterned, a template repeated like dovetail joints. We compared them to archived ULS tracks, the NSIDC Submarine Ice Draft Set, the same kind of data research labs use to map under-ice topography, shows natural variability, but this pattern did not fit the usual statistical scatter. You can look up the data set and the classic plots. They show keels as irregular, jagged monsters, not as repeating columns. Repeatability in nature isn't comfort, it's a signature. We eased the hull upward until the sail kissed the ice. The captain ordered the bow camera live. The edge of the hatch was a fringe of frost, and the Polinia was a black disk, calm and honest. But even the black water had edges, thin rims of blue that shimmered like a bruise under certain angles. Corby, who'd done spectrum checks on that blue flicker, muttered about a refractive signal he couldn't place. The periscope went up. One quick sweep. The optics took in the horizon. The camera sent a still to the bridge. We expected floes and cracked ice, maybe an old seal breathing. Instead, the lens caught a vertical column off the Polinia's edge, a finger of ice reaching down and then up again, a reef of prism, but inside it something glowed, a cold azure like deep-sea lanterns, pulsing slow as a heartbeat. For a second, the column looked like glass, and then like a throat. The sea showed a throat, and the throat blinked. A small team of technicians went out on the ice with the ice pilots. They took measurements. The ice chip we had from Karev was replicated in greater quantities now. Thin filaments embedded in the keel ice, aligned and regular, refracting light like optic fibers. The pilots muttered terms I did not know then. Cryolattice, brine channel filamentation, anisotropic inclusion. The instruments returned numbers that refused tidy classification. Corby ran the spectra, and the output gave non-standard peaks, not organic emission, nor simple mineral scatter. The lab report read like a conversation a man has when he doesn't want to be wrong in front of others. Microhook. You can read a spectrum and still not know who is talking. The tender radioed, "Surface confirmed. Ice pilots say you're green." That was the line in the report you could attach your name to. We vented a breath we did not realize we'd been holding. The bow hatch lifted. The ladder took guys up 2 at a time. The first men climbed out, boots cracking against the ice, the wind hitting their faces like a slap. They planted flags, mandatory procedure, and the photographer snapped the feel-good shot. Men on a black hole in a white desert. Photographs lie by omission. The camera never catches the glance.
We stood on the ice, because that's what sailors do. We mark our place. The photographer told everyone to smile and then stepped back a little too fast. He later said he saw movement at the Polinia's lip. I saw nothing at first. Then, as my eyes adjusted, something in the water rolled, and a ripple made the blue light flare like a weak heartbeat. We thought of fauna, maybe a bloom of dinoflagellates in a pocket of warmed brine, organisms glowing when disturbed, all plausible, except the light moved with intent. I'll be blunt, science and terror used the same vocabulary when the sample is wrong. There was light where no bioluminescent organism should have been in that abundance. Bioluminescence happens under the ice, and research shows organized luminous communities exist in polar waters. The literature records high-latitude bioluminescence associated with upwelling and dark winter ecology, but those signatures are typically diffuse and biological, not fixed into fiber-like structures embedded into ice keels. We had the science on one hand and an inexplicable fiber on the other. The difference mattered. When the biology looks engineered, you ask the wrong question first. Who made it? Instead of, what am I looking at? The first real break came when the pilot team radioed. They were not laughing. Their voice, a clipped professional voice used to calm risk assessments, collapsed into an almost human unease. Do not bring the ladder within 2 meters of the blue rim, the pilot said. It pulses when you come near. It moves in a way that is not current. The guys on the ice scooted back like a line of men who'd suddenly remembered a superstition. The photographer left the camera on the tripod and took a step away. He swore later he heard, as if through water, a single drawn breath, then silence. The audio was later scrubbed, and the scrubbed audio file became part of the thing nobody wanted to read aloud. Things that breathe in the dark make you count your breath. We should have left then. A sensible person would have said, pack up, close the hatch, send the sample back, call the fleet, go. But the human thing, curiosity, pressed by months of boredom and the small rush of discovery, pushed the ship to stay. The captain was tired and thin with strain. He asked for more samples and an expanded perimeter survey. He told himself this was reconnaissance, not a seance. The tender relayed an analyst message. Non-standard fiber confirmed, spectral peaks consistent with high silica glass-like inclusion suggest containment and further study. In hairline language, fiber looked like glass. There's precedent for silica inclusions in sea ice, but not in this architecture. The FLAP map we'd used to find the Polinia had not mentioned anything like it. The analysts on paper make precise statements that do not ease the gut. The second night, after surfacing, instruments failed in a way that felt theatrical. The ULS trace went flat for 10 minutes, not noise, but absence, then returned with a return reading that made the paper operator's pencil drop from his fingers. The trace printed vertical lines. Again, that pattern, but the signal amplitude was off the charts. Simultaneously, magnetometers gave a weak spike as if a large ferrous object had passed below us, but the hull's echo sounder and the towed array recorded nothing like a ship. The ship's GPS, a satellite feed, registered a 3-second skew. The latitude jumped a few meters and then corrected. Corby later said the skew looked like a digital artifact applied by an outside clock. That is bureaucratic phrasing for someone or something messed with our moment in time. Time that misbehaves is a dangerous kind of lie. The third day, the Polinia's blue ring convulsed. The men in the tender called it a flare at first, then they called it a bloom, then they stopped using words. The camera operator on our sail, a man who had snapped presidents and parades, watched the live feed, and for a moment the feed showed nothing. Then the camera filled with a slow vertical expansion of light, like a throat opening, and then a precise silhouette underneath it, angular, not exactly organic, not exactly mineral. It rose from the deep like a column of glass, and at the tip of the column was a crown of blue filaments, the fibers embedded in the ice, each like a living fiber optic cable. An object rises like a second sky. Panic is workmanlike when it arrives. It looks like people checking boxes. The captain shut down the mast cameras and ordered the tender to move off. We had to leave, the tender said. Their RIBs trawled the way in a hurry that suggested more than procedural caution. They wanted distance. Our captain finally agreed. He moved the boat out of the Polinia's edge and dove down, deeper than we'd planned.
That night, the night we left the Polinia, strange things happened inside the boat. The lights blinked in a pattern, 3 slow blinks, a pause, then 7 quick blinks. The radio whoops were weirdly melodic for a while. The intercom hummed like an insect. Men reported nightmares about standing on ice that peeled like wallpaper. People, including me, felt watched in the racks. The ship keeps memory, and memory scratches back. When we got back to the tender's coordinates, the ice formation had altered. The Polinja was larger, and the blue light had migrated to a new lip, like a campfire moving a few meters at a time. The tender's pilot said the flow had creeped in the night. That's the polite, morphological word for a dynamical shift. The word in my head was creep. The fiber filament samples we recovered from the ice were more numerous and indeed showed microfissures radiating like crystalline veins. We sent a sample to the tender's mobile lab. The lab gave us a dry little result summary. high silica matrix with organic trace amounts, filaments with hollow cores, spectral emission peaks under certain wavelengths that suggested a reactive photonic structure. Before we could parse the language, a Navy liaison came aboard and read us the lines from the legal folder we had all learned to fear. This incident is sensitive. You will not speak of the particulars to press or public. All data will be cataloged at the highest classification. No transfer without approval. In a single motion, they turned a real anomaly into an official dead letter. The men who'd been on the ice smiled like people who'd been at a funeral. Classification is a machine that eats a story and returns silence. Inevitably, questions leaked. One of the techs on the tender, a woman who later left the Navy and published under a pseudonym, talked in private to a documentary maker. She said, "The fibers looked like someone had threaded the ice with light. We thought engineered. We thought experiment. We thought worse, a new kind of organism." The interview never aired. The producer's hard drive later died, and the shirt he wore to the screening developed mildew and went missing from the edit room. Things like that happen when a story bumps into institutional friction. The universe has ways of losing the evidence you need. Back at Homeport, the paper trail went through filters. We wrote an incident report and then a sanitized report. The sanitized report read, "Unusual ice feature observed. Samples taken. No immediate hazard to navigation observed. Recommendation, further study." That's what the public gets when a Navy wants you to calm down. What we kept in our lockers was different. Sketches of the Polinia, prints of the fiber under microscope, diagrams of ULS readings. The captain kept a small envelope in his desk, labeled in block letters, "Restricted, do not release." He said nothing about the envelope except once, "Some things are not accidental. You can write a true sentence in a way meant to mislead." Months later, scientists published an article about bioluminescent communities under the Arctic ice and how upwelling can bring dense luminous organisms to the surface. It's legitimate and fascinating work. It explains some of what we saw, the way light can be concentrated, and how brine channels can hold organisms that glow when disturbed. But none of the papers I read then, and I read a lot, described silica filaments arranged in a lattice inside the ice, luminous and responsive. The science explained spectra, not pattern. The pattern was the problem. Science gives you language, but not necessarily comfort. There were other hints the Navy preferred to bury. I know men who were reassigned quietly within a week. The tender's ice pilots were sent to training that lasted months. The lead scientist got an offer to work at a classified lab 2 time zones away. A petty officer who filed a formal complaint about the missing video feed received a counseling letter about protocol adherence. I'm not suggesting a conspiracy with flags and maps. I'm reporting the things that happened in the small rooms where jobs are reassigned and stories are softened. The policy deck is blunt about risk. Surfacing through ice is allowable with a confirmed Polinia and with safety margins. The process uses satellite imagery, flap analysis, ULS scans, and, importantly, ice pilots to test the surface in person. This is real expertise. They gave us the go-ahead. But what's not in policy is how to classify something that may be both living and glass and responding to approach. There are no SOPs for that.
The manual gives you boxes. Life ignores the boxes. The end result was predictable in its bureaucratic efficiency. 2 reports were filed, one for internal investigation, one for public record. The public record said the Polinia was used as described. The samples were inconclusive. The internal report cataloged the filaments, the ULS anomalies, the spectral data, and a strange line in the video feed where the tower camera picked up a vertical object that could not be reconciled with sonar returns. The file was stamped and moved. Men who were asked to sign the internal report were careful with their words. We were ordered to keep quiet. The crew signed the standard non-disclosure forms that read like love letters to secrecy. You will not discuss without permission. They always framed it as national security. That cut the rumor off at its head for the public. Behind the envelope the captain held, we all kept a memory of blue light. Secrecy is a lid on a pan. It keeps the steam, but not the smell. Years later, when I read the open literature, I found the pieces scattered across legitimate research, ULS datasets and ice draft maps showing odd keels, papers on Arctic bioluminescence showing concentrated winter communities, studies and popular mechanics explainers on surfacing through ice and the FLAP method. None of those sources implied malice. They are tools and observations. But when you stitch them to the memory of a column of blue filaments and a polynya that moved as if it had agency, you make a different kind of picture. You learn to live with the oddness. You put pictures in envelopes. You sign official forms that say nothing. You go back to sea, and you keep one eye on the ice. In the end, the rule had teeth for a reason, and we'd bitten into those teeth out of curiosity and a little foolishness. We survived that mission. The scientists wrote their papers, and the Navy wrote its letters. The blue shards of ice went into labeled boxes that later disappeared into classified archives. The tender and our boat took the official line. I don't know what the fibers were. I don't know whether the polynya had a will, or whether we simply misread geological processes through the strange lens of human pattern seeking. What I do know is this: the ice formations that the rule told us to avoid had edges that breathed and lights that answered. And the one thing I carry is the memory of the captain's thermos steaming in the wind when he first said, "Never surface near those formations." He'd been trying, perhaps, to protect us from the bright thing waiting to be seen. If you ever find yourself on a recon boat staring at a polynya and your GPS says nothing is wrong, listen to the ULS. Look at the pattern of the keel. If the keels line up like joints in a machine, and if the light beneath the flow blinks like a slow lamp, do not climb out to mark your place. Push the hull down. Let the hole be someone else's photograph. Because the ocean keeps things in its mouth for a long time. And sometimes the thing inside the ice answers the question you didn't mean to ask.